Chapter 4, Question 1 and 2 are trying to get you to know the names or become familiar with the names of the different elements on the periodic table, and to associate those names with their symbols, so that when you see the symbols, you don't just read the letters, but you say the name of the compound. So for A, they just have a capital C, and that is carbon. Depending on how it's squished together, it can either be coal, or pencil lead, or diamond. And actually, diamond is the least stable form of carbon. Eventually, every diamond will spontaneously turn into coal. It takes a few million years, though. But C is carbon, and you could see that if you went on a periodic table, you can see carbon is right here. You see the capital C, and below it, it has the name carbon. Cl. Cl is chlorine. It's a light green, very toxic gas. You can bubble it through water, and then it will chlorinate the water, which will kill the bacteria in it. You can see on the left here that they're putting a rose in there, and it changes the color of the rose. And unfortunately, because it's toxic, it's also sometimes used in chemical warfare, which you see in the picture on the right. But Cl is chlorine, and you could see that on the periodic table. Chlorine is sort of in the top right. Go all the way to column or group 7A, and then down you see Cl, and below it the name chlorine. So you would write chlorine, the full name, for the answer for that, for B. C is just a capital I, and I is iodine. It's a dark solid, purple solid, that sublimes. And sublimation is when something goes directly from being a solid to a gas. It doesn't go from solid to liquid to gas, it just goes directly from solid to gas. And you can see that happening here. I for iodine. They sometimes iodize sea salt. They add iodine to it because you need it to create some of your thyroid hormones that set your metabolism. You can see that I is iodine. If you go way to the right, group or column 7A, go down, the capital I there is iodine. D, Hg. And so this Hg is mercury. It is the only metal that's a liquid at room temperature. A lot of these elements, the symbols resemble what the name is. For example, C for carbon or I for iodine, like the last couple that we saw. Hg, the ones that doesn't really sound like mercury. You can see Hg is down here in group 2b. Hg is mercury, and the elements whose symbols don't resemble their name is because these are elements that were discovered in antiquity. So the Greeks and Romans knew about them and had names for them already, and so the symbols are referencing their Greek or Roman names. And in this case, it's hydro-argurum, which hydro is kind of like water, argurum meant silver, so it's like water silver. And in Old English, you might see mercury referenced as quicksilver, so water silver. But that's because it's the only metal that's a liquid at room temperature. It's actually dense enough where a human could sit on top of it. And if you Google Mercury, National Geographic, man sitting on top, you'll see a picture of somebody doing just that. It evaporates very easily and then resolidifies inside of your lungs, so it's very toxic, and it can also cause dementia. So not something you'd want to play with necessarily. Ag. Ag is silver. You can see it crystallizing out of solution here. Silver, if you go to column or group 1b and go down, you see Ag, silver right there. Again, the Ag doesn't look like silver, but it's coming from the Latin word for silver, argentum, which the symbol is referencing that because the Romans knew about silver. They had discovered it. It was discovered before modern times. Interestingly, in some Romance languages, for example, French, Ag, argentum, is still used. The word for money in French is argent, so that's referencing the symbol. And also, the country Argentina shares the same root. Argentina means the land of silver because there was so much silver there. So that's E. F, Ar. Ar is argon. That's the gas that's inside of these sort of science toys that you sometimes see in stores. Ar is on the far right, group 8A, go down Ar, and you can see that that's argon. It's a pretty inert gas. In fact, all the gases in this 8A column or group, the vertical columns are called groups on the periodic table. Everything in group 8A is pretty inert. It doesn't react very much. So Ar is argon. B, capital B, is boron. And boron, when it burns, it creates this sort of bright green color. So if you ever see green in fireworks, it's coming from some sort of a boron compound. It's pretty toxic most of the time, unless it reacts with something before it reacts with your tissues. But boron, you could see it's in column 3A. You have the capital B there, and what you would want to write down as the answer is the full name, B-O-R-O-N, boron. H, Ni. Ni is nickel. It's used in a lot of batteries, especially with cadmium. You can see it's in column 8B, part 10. So that's Ni, nickel, is the name for that. So you would want to write down nickel for the full name for Ni. And when you run into these symbols from now on, you would want to say the name. So you wouldn't say Ni, you would say nickel. Okay, so that's question 1. And question 2 is basically the same thing. It says write the name of the element for each symbol. So we're becoming familiar with these characters that are going to enter on stage. So when they start to enact scenes in the drama of chemistry, we'll already have been introduced to these characters. We'll see them as individuals with full names. So He is helium. Helium is very light. It's on the top of the periodic table. In general, as you go down, the elements get heavier, and as you go up, they get lighter. And what that means is that helium floats, which is why we put it in balloons. It's actually a waste. Putting helium in balloons is almost a mind-boggling waste of a very precious resource. There's a lot of helium in outer space, but on Earth there's not too much. It's all produced by radioactive elements that are decaying in the crust of the Earth, which takes a long time, so it's not really renewable, and it's a finite resource. And helium is also very, very valuable because it's the element that humans know how to get the coldest of any element. So for anything that we need to do research for to get really, really cold, and one thing that we need helium for to get things really, really cold is MRI machines, so that you can diagnose illnesses in soft tissue in hospitals. You need helium for, and there's only so much of it, and to use it in balloons, it just escapes into outer space. Eventually we'll run out. But He is helium. You can see it's on the top right, the He, the name helium right under it. It's coming from actually the Greek word for the sun. Helios was the word for the sun. You might know from astronomy the heliocentric view of the solar system, or was the one that Copernicus came up with the sun in the center as opposed to the Earth. So that helium is coming from that name. And it's because there's a lot of helium in the sun. So people noticed that it was an element that hadn't been found yet or recognized yet on Earth, but they noticed there was a lot of it on the sun, so they called it helium. So for the answer for this one, you'd write down Helium, helium. P is phosphorus, and the place phosphorus burns very easily. It's not a particularly stable element. There are 3 different forms for it, kind of like with carbon, where you saw it when it's squeezed in different ways. It's either coal or pencil lead or diamond. So likewise, when phosphorus is squeezed in different ways, it can either be black or red or white, and each of those forms has slightly different properties. But all of them are pretty explosive. They burn very easily, and so the place where we would have seen phosphorus the most in our daily lives would be at the end of matches. There's the red form of phosphorus is what's responsible for the red at the end of a match. And it doesn't take very much friction for phosphorus to just combust, which is why it's so useful in matches. So phosphorus, you can see if you go to column or group 5A and you go down, you see the capital P. Notice the name for that is phosphorus. And phosphorus is just coming from a Greek word that means light, because it bursts into flame so easily. And so you would want to write that full name down for this one, Phosphorus. So phosphorus. Oh yeah, so it's the end of a match. And here you can see the Chlorine photography that allows you to see differences in heat and air currents. That's of somebody blowing out a match. All right, so Na is coming from, this was another element that the Romans had been familiar with. This is sodium. Here you can see sodium burning in air. So you're just heating up sodium and it's turning into these different forms. It's coming from the Roman name natrium. So that's why it doesn't resemble the English word, but that's in column or group 1A. Go down, you see the Na is sodium. So you would want to write down Sodium. One thing to note is that the sodium that they list on nutrition facts for food is not just pure sodium, it's actually a salt of sodium chloride, so sodium and chlorine together. It's interesting that sodium is a soft metal. You could cut it with a butter knife, and it's very reactive. It explodes in the air. If the air is humid enough, it'll just burst into flames in the air. It explodes when it comes into contact with water. So sodium's this explosive shiny metal. Chlorine is a toxic light yellow-green gas, and yet when they react with each other, they form a new compound that's essential for life. Sodium chloride, which is table salt. And that's what they list on nutrition facts as just sodium. But just keep in mind, that's not pure sodium. That's not sodium alone. That's sodium chloride, a separate compound. As is arsenic, which is often used as a poison, say, for example, a rat poison. And you can see arsenic. It's in column or group 5A. Go down. You see AS. The full name is arsenic, so you'd write ARSENIC. Ca is calcium. Calcium also reacts when it's in water, not as violently as sodium, though. As you can see here, it reacting with the water and producing these bubbles. I think sometimes people will associate calcium with milk or bones, and it's definitely used in that. But what some people don't realize is that it is truly a metal by itself. It's a shiny, bendable metal, and it doesn't look like bones by itself. It's only when it reacts with other stuff, like phosphates, that it takes on that white color. So calcium, you'd notice, is in column or group 2A, and then you see the Ca, that's calcium, so what you'd write down for this one is calcium, CaLCium is the full name for this. Br is bromine. It's a sort of dark brown red liquid that evaporates very easily. Almost always right above it you'll see the gas form, which is a slightly lighter orange, and it reacts very violently with aluminum, as you can see in this little video here, this video clip. So Br is bromine, and you can see it on the periodic table. It is on column 7A. Go down, it's right above iodine. So Br is bromine, Bromine. That's what you'd want to write down for question 2F. G, cadmium, that's what Cd is. It's in a lot of batteries along with nickel. In fact, a nickel-cadmium battery is a pretty standard battery. You can see what it looks like here. And cadmium is a transition metal. It's right above mercury. So in column 2B, group 2B, you would see it right here, the Cd, that's cadmium, right above mercury on the periodic table. H, silicon. So H is, well, okay, part H is Si. Si is silicon. It's a shiny metal. They use it a lot in computer chips. It's interesting. People think that if life on Earth is based on the element carbon, but people think that if there were another element that life could possibly be based on, so it would be very different from Earth, it would be silicon. And if you notice on the periodic table, Si, silicon, is just below carbon, so they share a lot of properties. Anything in the same column tends to share properties, but silicon and carbon are not just in the same column, they're right next to each other. So that would be silicon, Si. So in general, all these elements are fascinating. When you see the symbols for them, you would just want to be to associate those symbols with names, and preferably to think of those and to associate those names with colors and textures and behaviors that each of these elements have that define their characters in the drama of chemistry.